Good afternoon. Guten Tag. That's the extent of my German, I'm sorry. I'm Bethany Macri. I'm a software engineer on the core platform team at Etsy. That's an infrastructure team, as opposed to a product team. Today, I'll be talking about data migration at Etsy and how this project really is a shining example of our DevOps culture. So who is familiar with Etsy besides what Sebastian just said? OK, so a good number of people. For those who are not familiar, we are an e-commerce site for handmade and vintage goods. We are a Brooklyn-based company. We started in 2005, and we just went public. We have 20 million active users, transactions in nearly every country in the world, and just over 700 employees around the world, including an office here in Berlin. In terms of engineering, our sort of motto is code as craft. We are a LAMP stack. We are monolithic. We practice continuous integration, which I'll be discussing quite a bit today. We are a completely metrics-driven engineering organization, meaning we measure everything. Developers have access to almost every repository and production box. I think what really sets Etsy apart, however, is our engineering culture. We believe that failure is inevitable in a sufficiently complex system, and we have one. Failure is only big and expensive when it comes as a fundamental surprise. When you set your ego aside and realize that failure is inevitable, you can build for it and you can plan for it, and that's what we did in this project. And if failure is inevitable, people are not afraid to fail or afraid to talk about their failure. By removing fear, we have enabled honesty, and we have avoided a cover-your-ass engineering culture. Instead, we create tools and methods for preventing the same type of failure from happening again and again. For these reasons, we conduct blameless postmortems. We trust our engineers. A postmortem is an investigation into the environmental factors that enabled a particular failure. This is a somewhat common industry practice, but the fact that we conduct postmortems blamelessly might actually seem counterintuitive. After all, who's to blame? Who takes responsibility? Who fixes the bug? The answer is blamelessness does not mean no responsibility is taken. When you are trusted to act responsibly, and we are, you're expected to act responsibly. This manifests as engineers creating tools and systems to avoid those failures in the future. Why do we avoid expensive failure? What does it mean to us? What does it cost us when we fail? In a very direct way, money. We are a marketplace. If the site goes down, sellers can't sell items, sellers don't make money. If sellers don't make money, we don't make money. If people are not able to sign up or sign in, they can't purchase things. It costs engineering time to fix the bug, and engineers can be quite expensive. In a catastrophic case, we can lose data. We could lose customers permanently due to a bad experience. We could look bad, and as I mentioned, we just went public. This is not a time where we want to look like we don't know what we're doing. And if we do look like we don't know what we're doing, we also lose the ability to hire good talent. So while we recognize that failure is inevitable, we work in such a way that expensive failure is not inevitable. We acknowledge that failure is an option and ask ourselves, how do we fail in a small way? How do we fail privately? How do we fail in a way that does not cost us customers, money, data, and opportunity? We are confident that the solution to this is continuous integration. As I mentioned before, Etsy successfully practices continuous deployment. We push about 35 times daily on average. Our infrastructure and processes are so robust, we even trust non-engineers to push, and we require that engineers push on the very first day on the job. You can see pictured here Steffi on your right, who actually works in the Berlin office, leading a non-engineer through her first push. Now, the first push is very simple. It's adding your staff picture to the staff page on our website, but it's still a push to production. You can contrast this to other companies, some of which I've worked at, where non-engineers are likely not even allowed to look at the code base. I would offer that the more afraid you are to change your production environment, the more brittle you think your current production environment is. So how did we gain such confidence? Communication between developers and ops people. We communicate early, we communicate often. We communicate in a way that is not antagonistic. At some companies, developers build a feature and then lob it over the wall to ops people who say, you can't push this is crazy, it's not safe. And then the developers end up resenting the ops people from blocking them or from causing them to miss a deadline. Instead, we communicate throughout the life cycle of a feature or infrastructural change. Lastly, we do not, as developers, build a feature or do an upgrade or swap out a piece of infrastructure and then hand off the pager to an ops person. The developer is responsible for carrying the pager for the change they've made to the site. Another example of how responsibility can exist in a blameless culture. This is enabled not only by communication between developers and ops people, but also through being interdisciplinary. Being interdisciplinary, that is, ops people practicing developers, the developers practice, and vice versa, does not mean that they have the same skill set. We have really good developers who know their stuff. We have really good ops engineers who know their stuff. We have specialists. But the specialists cooperate. Whereas in a classical engineering organization, you have engineering in one silo and operations in another. Additionally, the more ops and developers know about one another's work, the more empathy they will have when, for example, something seems to be taking a long time. It enables understanding and patience. Automation and tools. As I said before, we measure everything. We then graph what we measure. We then alert on these graphs, and they allow us to spot anomalies easily and quickly. While we do have a team dedicated to making developer tools, we are also each responsible for building our own alerts and tools for a feature or piece of infrastructure that we build. Continuous integration. For us, a deploy is not a release. We do not have release managers, or maybe we are our own release managers. A deploy is rather a small change. Why? A small change is easier to write, it's easier to test, it's easier to understand, and it's easier for your peers to review. There's an adage that if you give an engineer a 50-line change, they'll spot 10 bugs in it. If you show the same engineer a 500-line change, they'll say, go ahead, push it, looks great. And a small change is easier to fix. If your changes are small, your failures are small. Or if your small change does cause a catastrophic failure, you at least know that it was your change and you're able to pinpoint it. We consistently conduct postmortems when things go wrong. We even have a tool to track our postmortems. Our postmortems are open to anyone, engineering or non-engineers. This helps us cross-pollinate our skills and our learning and bring it back to our respective teams. And again, they're blameless. The goal is to better understand the system so that we can make it safer, not to point fingers. Now, this is a journey. We haven't gotten everything right yet. We have been working on a data migration project for about 4 years now, and we still have 2 tables left to migrate. The goal of this data migration is to move off of Postgres onto MySQL. What's wrong with Postgres for us? When we began, we had one Postgres table. All of our data was on this database. If it and its secondary failed, we would lose data. It was a total single point of failure. As I mentioned, we have a LAMP stack. We're not used to reading and writing Postgres, and this has become increasingly so as we've moved off it. We have not been hiring for Postgres knowledge. So currently, we have one data engineer and one ops person who really know the internals of Postgres, and the rest of us rely quite heavily on them for their expertise. We experienced downtime during failover. When it failed entirely, and the site went down, until we failed over to the secondary. All of the recent tools that we had built to do schema changes are for our MySQL databases. Tools that stopped us from accidentally doing a bulk insert on a table or truncating a table. This means we could apply a bad schema change in our development environment. And we outsourced the maintenance of Postgres to an external company, so we could not be certain that the same change had been applied to production. We had no visibility. The Postgres schema had stored procedures in it. Stored procedures are difficult to read, difficult to reason about, and they're not a part of the monolithic stack that we're used to continuously deploying. So having stored procedures was a total anti-pattern for us. Plus, there was no way to add unit tests for them. In contrast, we horizontally scaled to MySQL databases. We call these the shards, and that's where the title of this talk comes from. Myself and 4 other engineers have been moving data from Postgres to the shards, and we have been called the Sharders. These MySQL shards are primary pairs that replicate to one another and have automatic failover. Each shard has different data on it, so when a shard goes down, the failure is minimized to the users only on that shard. For these databases, we have an in-house built ORM that we can easily add to, hack on, alter, and deploy because it's all within our own stack. Because they're primary pairs, we can apply schema changes easily. We take side A out, apply the schema change to it, put side A back in, and do the same for side B. And there's no downtime. So all of our data has been migrated except for 2 tables, receipts and transactions. That's because moving these receipts and transactions in terms of scope was extremely risky and complex. It was a little like playing Operation, which apparently is called Dr. Bibber over here. I had to ask a German friend. So no one wanted to touch these tables. And finally, our CTO said that he was going to drive to our data center in October and pull the Postgres plug. So we had to move the data. About the scope of receipts and transactions, our financial reports depend on them. As I said, we just went public. It's very important that our financial reports be accurate at this time. Things like gross merchandise sales and revenue. Our legal team depends on them. They use transaction data when complaints of fraud are escalated or in response to an official request, like a subpoena. Our analysts use them to track and predict buying patterns in the future. They use it to understand growth in geographical locations or to gain insight into buyer and seller patterns across categories of listings. Our risk team uses it. If the transaction value is high, the receipt is reviewed for fraud or policy violation. Community support uses it. Receipts are used to answer customers who have questions after they buy something. Now, when people have already put down money on something, they can be quite emotional and angry, and this is not a state that we want our customers to be in. So we want to be able to give them correct answers. Many engineering teams at Etsy rely on this data. Features like checkout, our shop dashboard for sellers, shipping labels, all interface with receipt and transaction data. We were at risk for data corruption and loss that affected all of these teams and features. Because of the scope of receipts and transactions, because the scope of what receipts and transactions affected was so large, and due to the time constraint, we had to go fast and we had to be safe. The first thing we did was tell the engineering organization that we were completing the migration. These are actual people from Etsy. This is not a stock photo, by the way. We did this so that when we broke something, people would know it was probably us, and they would alert us to the problem. We expected to fail. We just did not know how we would fail. We wanted to keep our failures small as possible, and we wanted to make fixing them as quick as possible. So the second thing we did was we put everything behind an is-enabled flag. This allowed us to keep our changes tiny, which made testing much easier and failures easier to spot. Teeing is the word that we use to describe when we write to the MySQL shards every time we write to Postgres. So behind each config flag, we teed creates by creating a record on the MySQL shards every time a record was created on the Postgres database. Then we moved throughout the code base and teed updates, so that when an update statement was executed on a record on Postgres, that update statement would also be executed on the corresponding record on the MySQL shards. These feature flags allowed us as a team to work in parallel and to ramp up each site individually, so we could incrementally gain confidence that we were teeing correctly at each site. Failure 1. We allow digital items to be purchased on our website, such as a knitting pattern. I pushed a change that checked if a receipt was an instance of a class that inherited from the new receipt model instead of the old one. We hadn't backfilled yet, so there was no record and therefore no corresponding ORM object. That is all to say, customers could log in and purchase a digital listing and check out, but no digital receipts were being created. This caused problems because the customer receives the digital listing with the receipt. So I pushed my change, and I did not see any immediate negative effects. Within 20 minutes, however, I was getting pinged by the shop management team who owns the digital listings feature. The good news is that the first part of our plan worked. Our change set was small, and the shop management team knew that it was me who had made the change. A quick check on our version control system told them that I was the last one to touch the file that was showing up in the page they were receiving. I was able to roll forward with a change instead of ramping down the site, and it was faster that way and only required one push. Interestingly, this had gotten to production without issue. It had passed all of our automated tests. How could this be? There were no tests for this feature. We keep our test suite small. We think it's better to have faster pushes than to have 100% test coverage. Yes, sometimes it bites us, and in this case it did, but we create safety nets for ourselves by having alerts like these and the ability to push a fix quickly. The shop management team had not written tests for the original digital purchases feature, but they had created an alert that said, measure the number of digital receipts created, and if after 20 minutes that number is 0, page the team. That's what happened, and that's what's shown on this graph. I could then parse these logs and write a backfill script so that people could get their purchases. Even though I'm a developer and not an ops person, I have access to all of the production boxes. So after getting a code review from someone on the shop management team, I was able to run it quickly. Problem solved. So we had been bitten by this lack of test coverage. I learned a huge lesson here, and this is when me and the rest of the Sharders really dug in and we became our own QA team. We have a development environment at Etsy that is maintained by our developer tools team. It's completely sandboxed from the production environment. Knowing what I now knew about limited test coverage, I had 3 options. I could ask all 30+ engineering teams at Etsy to stop what they were doing and write unit tests for all code that may or may not be affected by receipts and transactions code. Option 2, I could stop what I was doing and write those unit tests myself. Option 3, which was the option I chose, was to use an existing tool, our development environment, to create a test shop where I happened to sell ice cream, my nephew, and pictures of Prince. So we, the Sharders, all shared this shop, and this allowed us to make mock purchases to see whether the code was behaving as we expected before we pushed it to production. We all have access to the development databases. You're noticing a pattern here with developers having access to boxes. So we could manually run queries to see whether records on the Sharder databases had been updated, and thus if our teeing had worked. Thus, we were acknowledging that the code we were writing could fail, and it had failed. And this is another example where we hope to mitigate that by using tools. We failed again. We missed a null check. Before backfilling records from Postgres to the MySQL shards, we need to truncate the receipts and transaction tables on the shards that we had been teeing to in order to avoid duplicate entries. We did this and started seeing these errors in a tool called Supergrep. Supergrep tails our error logs and presents them in a web interface for arguably easier parsing by the human eye. The method being called here is called frequently and caused Supergrep to spew. So in the browser, you could see that this error was flooding the tool. It's a very useful tool, and I'll often keep it open on my secondary monitor as I'm pushing code because movement on it is frequently telling of the health of the site. This is yet another example of how our tooling helped us detect an issue relatively quickly. Again, we had this behind a feature flag, and we turned all of the other feature flags at all of the other update sites down in case we had missed other null checks. So we had built knobs, essentially, with all of our code that we could turn down when things went wrong. Using these config flags was not clever. Not doing the clever thing is not always the most interesting or the most fun. But these feature flags, in this case and in other cases, saved us because the errors had become so frequent that they made Supergrep unusable for other developers. Again, we were surprised by how this failed, but we were not fundamentally surprised by failure itself. And we had shipped code that had an off switch. Failure 3, we broke replication on the shards. We denormalized data at Etsy. For performance reasons, we keep all of a user's data or all of a shop's data on the same shard. We have, therefore, denormalized data sharded by shop ID or user ID. In our ORM, we have a hook before a store method to the shop receipts table that says, if there is a create on the shop receipts table, create a record on the user receipts table, and likewise for updating records on the shop receipts table. Our backfill script, however, the script that was moving records from Postgres to MySQL, was not using the variant framework because the variant framework does not support bulk inserts, and we wanted our backfill script to run quickly. The backfill created the record on the shop receipts and on the user receipts table. Then a code path was triggered, which caused that record to be updated. The variant framework updated the record on the shop receipts table. So far, so good. Then the variant framework went to update the record on the user receipts table and did not find the record on the user receipts table. And in a behavior that surprised us, it forced a create on the user receipts table. As I mentioned before, our MySQL shards are replicants. We have side A and side B. It then tried to replicate to side B of the user receipts table. And the problem was pinning. We have a primary setup. We write to both sides. We pin by the user ID mod2. The pinning done by the variant framework and the pinning done by the backfill script were on different sides of the user receipts table. So when the side that the force create happened on tried to replicate to the other side, replication broke and it hung on that query. Jeremy, one of our database administrators, got paged when replication broke. This graph, which shows the time it's taking the shards to replicate data from one side to the other. The huge spike on the right coincided perfectly with when the backfill started to run. Ram, the person who was running the backfill, had told the database administrators that he was about to run a backfill script and asked that if they saw something, they say something to him. When Jeremy got paged, instead of fixing it himself, he told Ram to run a script that skipped the hanging statement and would get replication back to a normal state. Ram ran that script, then stopped the backfill and cleared the job queue of all pending backfill jobs, all within a span of a few minutes. This was enabled by our tooling. I think this shows cross-team communication and pollination of knowledge, as well as an excellent use of metrics and tooling. All of this is to say that during the data migration project, we were working with data, features, and infrastructure that was both widespread across the code base and fairly elaborate. And as a result, we failed in unexpected ways. This is not new to us at Etsy. We fail all the time. We know that we have a complex system. We know that we make mistakes. We are humbled by the fact that we build things that break. Or in the case of what's represented here on this slide, we might accidentally push to the iTunes store 4 stars and a horse instead of 4.5 stars. A culture of blamelessness does not mean a culture with no responsibility. At every step of this sharding project, we took responsibility for the changes we were making. We communicated them early, and we kept our communication loops tight. By acknowledging that failure was inevitable, we created a safety net for ourselves. You can create tooling that makes it easy to revert or roll forward with a change. You can add metrics around failure scenarios, and you can alert on those metrics. At Etsy, we not only accept failure, we celebrate it, because we know it makes us better. Each year, we award the person who broke the site in the most magnificent way the 3-armed sweater award. We even had an Etsy seller make us a physical 3-armed sweater that hangs on the ceiling above the operations team. I believe we do this because we've learned not to fail in huge, expensive ways. And if we do, we memorialize the event in a postmortem and we learn from it. Thank you. I think we have time for questions if people have questions.
Yes, if you got any more questions, please feel free to ask. Do we have another microphone?
Hi.
Hi.
Thanks for the talk. You seem to suggest that you use a lot of feature toggles. At what point do feature toggles actually become permanent fixtures in your code base, and do you go back and clean them up?
So the question, did everyone hear the question? We use a lot of feature flags. He referred to them as feature toggles, which is a good way to think of them. He was asking at what point they become a permanent fixture in our code base, and do we go back and clean them up? So I think what you're really asking about is if they turn into technical debt or cruft. They do, and we have to consciously go back and clean them up, and there is no schedule for that. It's on an ad hoc basis. So yes, they at times have become permanent fixtures. That is not a great thing, and we have to go back and manually remove them. And we plan to for this project.
Hi.
Hi.
How do you actually do the postmortems, and who does attend, and how often? Yeah.
So we do postmortems. There are varying degrees of severity. A severity level 1 is a total site outage. Luckily, that does not happen very often. A severity 5 would be no user-facing outage at all, but something that could turn into a problem in the future. When these events happen and they're scattered, there's no regular frequency. We cannot predict when they happen. But when they do happen, we try to hold the postmortem within 1 week of the event. One person conducts the postmortem. So one person is the person asking the questions. The people who are at the postmortem are primarily the people who were involved in the event. So the person who caused the bug, the person who fixed the bug, anyone who was on call at the time, anyone who was involved in the discussion of fixing the bug, and then also anyone else who wants to attend. And that's where kind of the power of our postmortems come from, because people attend and then they go back and share with their teams what they've learned. Was that what you were asking? Okay. Oh, we collect the issues. So I actually wrote a tool called Morgue, M-O-R-G-U-E, and it's open sourced, and that's how we keep track of our postmortems. So it's on GitHub.
I love how you pull DevOps to also cover non-technical people. The only question I have is, do you have any compliance or risk management issues with having whatever many thousands admins on your production servers and seeing production live data? We have a lot of data privacy laws here in Germany which make this really difficult to convince the non-technical people that it's okay if 5,000 people can see user data, private addresses, and so on.
So you're asking if we are putting ourselves at risk by allowing not only all engineers but non-engineers to push code?
No, I ask if this is a compliance problem, if you have compliance problems or problems with the authority by doing that. Because if I would be doing that here, I would probably go to jail for allowing too many people to see customer data.
Okay, understood. So this is a very timely question. There was no compliance issue before we went public. Now that we've gone public, there are certain files that have yet to be decided, and this is a current project, how to split those files off into sort of their own. We have a monolithic website, but they're going to need to be almost their own service. And no one's going to be allowed to touch those people but for the people who are approved.
Do you publish how you do that? I would love to see it.
It's not been done yet, but I'm guessing there will be a talk on it. We tend to talk a lot. Any other questions?
Yeah,
Hi.
please. I'm curious about how many feature toggles you talk about. How many, do you have a rough number?
Of feature checks?
Yeah.
Total?
Total, yeah.
Oh, gosh. Too many to count, and it's a point of contention at Etsy. Every time we brainstorm about what we want to make better, we say we want to make our config file, where all these feature flags live, we want to make it smaller. So I don't have a number for you. My answer is too many.
Thousands or millions, so?
Oh, thousands.
Okay.
Yeah.
One more question here.
Yeah, with respect to the other talks we heard, like, did you at any point consider breaking up the monolith in multiple services? And if not, why not? I mean, or don't you feel any pain with having a monolith?
Not in my tenure at Etsy has that been considered. We used to have services, and we actually transitioned into a monolithic code base, which, as I understand it, is kind of backwards. Do we feel pain? It makes it easier to deploy to. But no, I don't hear any discussion of us moving into services or microservices anytime soon. Yes.
Do you think like this relates somehow to your organizational structure, that you're able to run a monolith?
So
and
I
like
think
the practices you have?
So the question was, does this relate to our organizational structure? And the second part of the question was?
And your development practices.
And our development practices. I think that it relates to our engineering culture, which is very open and encourages everyone to have their hands in everything. So except for payments, which for compliance reasons has to be its own service, and Java, and the search stack, which is written in Java, everyone is encouraged to hack on everything. And so the monolithic code base does enable that. So in that way, I think it is connected to our engineering culture.
Some more questions? No? Okay, 1 second.
Thank you for your awesome talk. So I guess that you're very homogeneous in your company. All your colleagues think the same, and you're not too big, I think. How many colleagues have you got?
Engineers total, or on my team?
No, engineers in total.
Engineers total, we have just over 200 worldwide, and that includes ops people.
Okay.
Yeah. And was your question, do we all think the same?
Kind of being homogeneous.
We do not. So we all enjoy this culture, but we have very heated technical debates. I think that just because you've laid the foundation and these kind of principles are agreed upon, we still have, there's still much argument about what to work on next or how to implement that next feature or infrastructural change.
And the fluctuation, is it high or low?
You mean engineers leaving the organization? Mm-hmm. It seems to be low. It's very low on my team, and seems to be on all infrastructure teams. And I don't know the reason for that. But product teams, there seems to be more turnover. I don't know if that's goes along with being a product engineer and you want to churn things out faster versus infrastructural engineers work on projects for a longer time, but that's the pattern. Thank you. Mm-hmm. Thank you.
One more question.
Oh, sorry.
Yeah. No. Is there a question? Then, yeah. Thank you very much for the great talk. Here's one question. Okay, last opportunity. Speak loud.
How do you ensure it doesn't turn into an integrated spaghetti system? What do you do to guarantee the structure of your monolith and making sure it remains maintainable over time?
That is the job of my team. There is no structure to it at all. It happens to be part of the culture that when new features are being built, people come to us and ask us to advise on the architecture of the feature and if it's safe and if it is maintainable. But there is no formal way that we do that. And so it's arguable whether or not we're doing that well.
Okay,
Thanks.
so thank you very much. Warm applause, please.